Good afternoon. My name is Xiaojiang James Du. I'm a professor from Stevens Institute of Technology. Today I'll talk about our work on IoT security, titled Detecting and Handling IoT Interaction Threat in Multi-Platform, Multi-Control Channel Smart Homes. So this is joint work with my previous PhD student, Haotian, and my collaborator, Qiang. So in this work, we studied the interaction threat. The two main new aspects, one is we studied the multi-IoT platforms. The other is the multi-control channels, so I'll briefly explain them. Multi-platform is pretty easy to understand. It has been existing for many years, where users have devices connect to different IoT platforms, such as Sense and SmartThings, IFTTT, Google, Alexa, and so on. Okay, so basically, many users they have devices connect to more than one IoT platforms, and one device may connect to several IoT platforms, and those devices are controlled by every connected platform. Okay. It's unlikely that one platform can view or control all the devices in a smart home. The other issue that we studied, which is a new thing, is multi-control channel. So an IoT platform supports several control channels, including the well-known automation apps, which runs on the cloud, on the platform that performs automation. But in addition, there are other control channels, such as a mobile phone has a mobile companion app. In addition, there's voice command. The user speaks his command, like the close the lock or turn on the light to the smart speaker. In addition, there are also physical channels, including there are some IoT devices, they have the user interface. You can push a button or touch screen to control the IoT devices and so on. Those control channels, they are heterogeneous, and for example, the automation apps, basically they are code, they run automatically. Other control channels typically are initiated by user operations. Okay. So this shows a typical IoT setting where you have devices at home, and there may be an IoT hub or several IoT hubs. Those devices connect to the platform. Most of them are cloud-based platform. Of course, there are some local platforms. So this page just gives some background information. I'll go quickly. So smart homes support home automation, which is one of the main features that people use smart IoT devices. And most of the home automation rules follow the trigger condition action paradigm. I'll give a very simple example here. But in the example here is the trigger is when the motion is detected, for example, by a motion sensor. And then it will check the condition, see if the condition is true or false. In this case, the condition is if the owner's location is not closed, which means the owner is not home, then there's something wrong, maybe an intruder, then the action is to sound the alarm. Of course, users can use different automation rules. Interaction threats also have been studied. There are a number of works in the past. In short, it's called cross-app interference threat, CAI. It could be also cross-rule. Okay. Here are two simple examples to help people who are not working in IoT. So the first example is there are two automation rules user installed. The first one is when user arrives home, then the door will automatically unlock. The second rule, user use another app or interface to set up is when it's 11 p.m. or after 11 p.m., it will automatically lock the door. As you can see, those two actions, they could cause conflict. The other example is there are also two apps or rules. The first app says if it's 6 p.m., then automatically turn on the heater. The second one is when the temperature is high, it will open the window. As you can see, those two can cause interaction, conflict, where when the heater turns on, after some time, the temperature will rise, and which could cause the window to open. If after 6 p.m. the user is not home, then what happens is the heater will be automatically turned on, and then after some time, the window will be opened based on second automation app or rule. Okay. So again, there have been a number of works studied the CAI and proposed the solution. The current solution mainly is to do the detection of the CAI threat, and most of them are using the pattern abstraction plus some static verification. Very few of them consider the multi-platform, and based on our best knowledge, none of them consider the multi-control channel thing. Okay. So again, this paper, this research, the two main new aspects. One is multi-platform. I'm using the same example, but on the left side is on two different platforms. Okay, so like at 6 p.m. you have a rule running on platform A, say send some smart things. When 6 p.m. you'll turn on the heater, and the difference is the second rule is configured or set it up on a different platform, maybe IFTTT or Google Home, where again, the rule is the same. When the temperature exceeds certain value, open the window. Okay, if those two rules are on the same platform, it's much easier to detect. However, if they are on different platforms, it's actually non-trivial to detect them. Okay, there are some work considered multi-platform. However, the solution is basically like I'll discuss the detail later. Okay, which is not effective. So what we studied, the other new aspect is considered the multiple control channel, specifically including manual channels. Okay, so on the right side, there's an example showing the what we call CMAI threat, so including manual control and automation interaction threat. In this case, the user manually set the home mode. There's like a home security system. You can push a button or use the GUI interface touch screen to set the mode. So the user manually set it to vacation mode. This will have interaction with an automation rule running on platform A, where the automation rule is when the front door is open, if the home mode is away, then there could be like an intruder or something like that. So it will at least turn on the security camera to record things. However, the manual control channel set the mode to vacation mode, so it will disable the rule to run, which will not let the camera to be turned on. So if there's intruders, it will not be recorded. Okay. For the existing work, they couldn't handle the multi-platform and/or multi-control channel interaction well due to several reasons. One is the previous work, they typically don't have global view or global control. One of the work, they did study the multi-platform. However, the approach was to rewrite the automation rules and migrate them from multiple platform to one platform. However, as you can see, this involves a lot of effort to like rewrite apps and move from one platform to another platform, which is non-trivial, and also a lot of effort. So it's not very feasible solution. The other limitation is the existing work, they cannot capture the manual control. Okay? Because the reason is the manual control, they do not go through the automation apps. So the existing solution that use the automation apps to do the code instrumentation or API hook, it won't work. Okay? Because you cannot capture the manual control, like push a button or set something, then you will not be able to detect the interaction. Okay? The other limitation is the prior work, they cannot send corrective command. So they could block a command that should not be sent, but what they couldn't do is, say if something already happened, like some interaction caused the door opened and they shouldn't open, what they could not do is to send a corrective command to close the lock. So those are the limitations of the prior work. So what we proposed is a tool we call the IoTMediator. The structure is showing here. It has several parts. On one side, the IoTMediator connects to all the IoT devices at home through the device gateway, which is part of the mediator. On the other side, the IoTMediator also connects to the multiple IoT platforms, and we implemented those using several real IoT platforms. Okay. So I'm going to discuss the details later, but briefly I'll talk about the different part here. For the mediator, besides connecting the device and the platform, it has two main functions. One is the threat detection, including the static interaction candidate screening, and then dynamic verification. Again, I'll talk about each part in detail later. And then once the threat being detected, we'll do handling as well, where we will generate options to let the user choose. And then after user choose the option, we will do the implementation enforcement. Okay. So for the multi-control channel, I'm going to give some examples. On the left side are the traditional CAI patterns. There are different patterns, including one automation rule enabled the condition of another rule, or disabled, or there could be race condition where two rules being triggered at the same time, but they have different actions, or chain execution, and so on. So due to the time reason, I'm not going to explain everything. It's should be pretty straightforward. On the right side are the interactions involved in manual control, which we presented in this paper. The types are similar, but the main difference is one of them is like a manual control. Okay, so for example, in the first example, chained execution on the right side, where the user manually turn on the switch. So the switch being turned on, and this manual control channel, the action, the result will interact with the automation rule underneath, which where the switch, if it's on, it will turn off the camera. Typically, this app is when the user is home, it will turn off the camera inside the home for privacy reason. However, as you can see, this could cause unwanted chain execution. The other one is the, let's just look at the condition disabling. In this case, again, the user set the home mode to like a home. It will disable the automation rule where need the home mode to be awake. Okay. Right. For the detection, so I'm going to talk about some details. It has the candidate screening. It's mainly done, offline. So basically, what we do is we obtain all the automation rules for this particular smart home, and then we also obtain all the commands supported by the IoT device installed in this home, and then we check the rules and the command we obtained against all the interaction pattern. Okay. And we see if there's a potential cause interaction. Okay. Of course, if there's potential, does not necessarily mean in the runtime they will actually have interaction. So that's why we have the dynamic verification part, where what we do is for each potential candidate, we generate a sequence of assertion. Only when all of the assertions are true, then during the runtime, we use the runtime event and data to check the assertion. And only all of them are true, then that means actual interaction happens. Okay. Due to the time reason, I will not be able to explain the example. It should be straightforward. So we also provide proper handling compared to existing or previous work. In the previous work, mainly the handling is to let the user reconfigure apps or specify some particular policies, which is non-trivial for general publics. In our case, we generate options, and the user just need to choose, and we have explanations. Okay. So those are the some examples of the handling option generated by our tool automatically. So I'll just briefly talk about this chain execution. This means there's the automation rule 1 run, but after the automation rule run, it will cause the second rule to run. However, so this is called chain execution. So we provide options to let the user choose either not execute A2 or execute A2 or execute under certain condition. I'm running out of time, so we did evaluation on 2 real smart home testbed. One is an apartment, the other is house, and we in this case we have 4 IoT platform: Samsung Smart Things, IFTTT, Google, and OpenHub, and we have over 20 devices and automation rules. So I'm just going to briefly present you the result. So we have the test group where the 2 rules or 1 rule and 1 manual control could have interactions. We compared with 2 state-of-art related work. One is IoT Guard, the other is IoT Safe, both published in top 4 conferences. So as you can see, for IoT Guard and IoT Safe, they can only detect 3 or 4 out of the over 10 cases, where in our cases we can detect all of them. The other comparison is the handling. So for IoT Guard and IoT Safe, they can only properly handle 1 out of the over 10 cases. We can handle all of them. So I'm gonna, and we measured the delay because we added 1 more hop. So the overall delay is about 0.7 second, which is not too long. So let me conclude. So basically, we considered the multi-platform and the multi-control channel in smart home IoT system, and we designed a tool to not only detect but also provide tailored handling. So we used the 2 real-world testbed to measure the performance compared with 2 existing work, which shows we have good performance. So that's it.
Okay, let's thank our speaker. And